So welcome back to the GDC English YouTube channel. So today we are going to discuss about quality control tests that are related to oral solid dosage form. So we are going to discuss. So welcome back to the GDC English. Okay, I hope you guys able to hear my voice. Yeah. So today we are going to discuss about the quality control tests that are being done for the oral solid dosage form. So oral solid dosage form, what are the oral solid dosage form? So these are the examples of, first we talk about a kind of unit dosage form. So they are mainly given or are prepared in a formulation type that is in the form of unit dosage form. We have to take a certain units, like we are taking 1 capsule, 2 capsule, 3 capsules. Okay, in a same manner we are also taking the tablets. So there are some other quality control tests that are related to the solid oral dosage form that can be asked in your coming exam, that is going to be the Tamil Nadu Drug Inspector exam. So we are mainly going to study about all the quality control tests related to the oral solid dosage form that are going to be very important from your exam point of view. So yes, first we have to discuss a basic concept. Okay, first we have to discuss about what the tablet actually is. What is tablet? Yes, starting from the basic and then we go to the quality control test. Yes, so coming to the slide, the tablet is what? The tablet is a kind of unit dosage form. So yes, we can be able to dispense the units of it. Okay, either the 1 unit, 2, 3, 4, whatever the number we are willing to take, and they will mainly comes into the stripped package, okay, or into a bottle form. Yeah. Yes. So tablet is a kind of unit dosage form that will mainly contain the drug substance with or without the suitable diluents. Yes. So the diluent can be present or can't or can not be present. So if the quantity of the drug, is sufficient, is high, or the dose of the drug is high, quantity or the dose of the drug is high, then we are not going to use these diluent because they are mainly the bulk formers. So when we are going to use these diluent, we are mainly or basically being used these kind of diluent when the tablet mass or the dosage of that particular API is very less. And there's a difference in between. They are talking about the drug substance and the drug product. A drug substance is a combination of both API plus that of excipients. Yes. And so the whole definition of the tablet then comes to our mind, or is now can we, understand a little bit with a higher understanding that it is a kind of unit dosage form that will mainly contain the drug substance that is going to be the API plus excipient itself, that may or may not contain diluent. Yes, it is mainly depend upon the concentration of or the dosage or the dose of that particular drug. If the dose of that particular drug is going to be very high, then we are not going to be use the diluents. If the dose of that drug is very low, then we have to use the main bulk formers that are known as diluents. Yes, and are mainly prepared by either by the compression, either by the molding or the molding process. Okay, so then we discuss about the type of the tablet and the classes of the tablets. Yes, so the classes of the tablet, the tablet can be the most commonly used tablet that are present into market, that 90% of the tablet are the orally ingested tablet. Yes, the oral tablet for the ingestion. We mainly take these kind of tablet through our mouth. So the first comes is the compressed tablet. We can also say that it is a kind of direct compressible tablet. And then we comes to the multiple compressed tablet. Yes, the multiple compressed tablet is mainly manufactured by an instrument or a apparatus that is known as versopress. Okay, and this multiple compressed tablet that will mainly having the different component one over the another. We can also known to be as the layered tablet, having different layers of components. Layered tablet. These layered tablets are mainly formed with the help of the equipment that is known as versopress. Okay, yes. Then we comes to the tablet that are known as enteric coated in nature. Means they are mainly contain the API that is not resistant or can be degraded in the presence of acids. That's why we are using the enteric polymer. Okay, there are different kind of enteric polymer, like you can say 𝘎𝙎𝙎 LRS is a very good kind of enteric polymer. Yes, they are mainly protecting the drug from the harsh acidic environment of the GI tract. Then we comes to the chewable tablets. Yes, the chewable tablet that is chewed into our mouth cavity and will release all its drug content into the mouth cavity. Then we comes to the film coated tablet. Yes, they are the film coated tablet having a certain film, thin film. In order to taste masking, we are sometimes produce the sugar coated tablet, or the other times we have to produce the film coated tablet. They have a thin film over there. Okay, then we comes to a sugar coated tablet. Yes, there are different kind of steps. We are only know also know that they are mainly like different kind of syruping, okay, edge round off, glossing, and color addition. That are the different steps of these sugar coated tablet and having their disintegration time. Yes, for all the tablets, the disintegration time is going to be very important. So for the sugar coated tablet, the disintegration time is what, 60 minutes. Okay, and then we comes to a controlled release tablet. All are the examples of the tablet that are being ingested orally. Okay, that are being ingested, not orally, they are being ingested, means we have to take them inside the body. Okay, then we comes to a specific category, that is mainly the oral, or the tablet that is being placed into our oral cavity. Okay, the first comes is the buccal tablet. Yes, they are mainly present into the buccal cavity. This is the buccal cavity, a buccal pouch that is mainly lies in between your cheek and that of your jaw, is known as the buccal tablet. Okay, then we comes to the pouches and lozenges. Okay, yes, pouches and lozenges. Then the sublingual tablet. Yes, we are mainly know the example of nitroglycerin tablet that are can be also written as NG. They are going to be the sublingual tablet. Okay, they are just placed beneath the tongue in order to show their action. Yes, then we comes to the pouches and lozenges. The important question that arise from the pouches and lozenges are, the lozenges is mainly produced by the process that is known as molding. Okay, and the pouches is mainly produced by the process or manufactured by the process of compression. Yes, then we comes to a dental cone. Dental cone that is being placed into the socket, into the root socket of our teeth. The dental cone have to be placed. So all these kind of tablet has to be given into the mouth cavity, not to be ingested inside the body. The ingested one we have discussed first. Then we are mainly discussing about the tablet that are given to the only to the buccal cavity. Then we comes to the tablet that are given by the other routes. Yes, so they can be the depot or the implants and the vaginal tablets. Okay, the vaginal tablets. Sometimes the vaginal tablets. So the diluent that is being used in a vaginal tablet should be of that much property or hydrophilic in nature, or is of that kind that can be solubilized into that particular vaginal cavity, because the fluid of the vagina is very less. Okay, that's why we have to use that kind of diluents in case of vaginal tablets. Okay, yes, vaginal suppositories, we are also known as vaginal suppositories, as that we will going to discuss in our semi-solid class, like pessaries. Okay, the tablet that are used to prepare the solution is the fourth category of tablet. Yes, it comes to the effervescent tablet having its disintegration time of about 5 minutes. Then comes to the dispersible tablet that having its disintegration time of 3 minutes. Then we comes to the hypodermic tablet. Okay, and then we comes to a tablet triturate. Yes, these tablet triturate has to be triturated first, then have to be mixed into a particular liquid solvent that is being added to that particular volume of salt or water or the solvent that has to be ingested by the patient. Yes, so these are going to be different kind of tablet or the tablet types. Yes, coming towards our next evaluation parameters or the quality control test for that of the tablets. Yeah, there are two categories of test. The first one is the non-official kind of test that are not being mentioned into the pharmacopoeia. Yes, as the name indicates. And the second one is going to be the official test. So first we have to discuss about the non-official test that are not that much mandatory but are important for your. So first the question arises, so why we are doing the non-official test? Because we are doing the non-official test because they are very going to be very important from the preparation of the preparation of tablet perspective, but they are not mentioned into the pharmacopoeia. But we have to do these kind of tests in order to ensure that tablet is of good quality. Okay, so the general appearance, the first non-official test is the general appearance test. Yes, as you know, we appear from the outside as same as that of the tablet. The one who sees us, okay, from a far away is mainly sees our general appearances. So general appearances will mainly contain what? The size and the shape of our body. So in the same way, the size and the shape of the tablet is comes to the first, and then we comes to the organoleptic property. Yes, all the properties that can be felt by the organs, like either it is tongue, nose, eye, or eyes. Okay, so it's known as the organoleptic property. Okay, and the second is going to be the hardness. Okay, we have to measure the hardness of that particular tablet. Then we comes to the official test. The first official test, the friability. We have to check if the friability about the like how friable a given drug is, and on the basis of its friability we have to decide the package in which the given drug have to be packed and the mode of transportation. Okay, so there's not more than 5% of loss that can't be tolerated in the case of friability. Then we comes to the weight variation test. Then again comes to the content uniformity test. Then the disintegration test or disintegration time we have to check, and the dissolution time, that is mainly related to the efficacy of that particular drug. Okay, the content uniformity is also related to the efficacy of that particular tablet that is present into the drug. Yes, coming towards, or let's study about these different kind of test one by one. So first we are going to discuss about the general appearance, the kind of thing that we are going to see when we look the tablet at first sight. Okay, yeah, this is a person that is looking at a tablet at first sight. So what he see in a tablet? The size of a tablet or the shape of a tablet. Yes, we have to discuss about the size and the shape of the tablet. So the total thickness of the tablet has to be determined by the, so this is the kind of tablet we have to draw. Okay, yeah, okay, so this is a kind of tablet. If the upper portion, as in the case of like king, the upper portion is mainly a crown. So same for that of the tablet, the upper portion of the tablet is the crown. Okay, yes, but if we are discussing about that of the capsule, the upper portion is mainly, the lower portion is the body. Okay, and upper portion is mainly what? Head. So if we want to determine only the crown thickness, as we discussed, we have to use the micrometer. So this is mainly the micrometer. Yes, it will mainly helpful in determination of that particular crown thickness or a smaller thickness of the tablet. Okay, yeah. And if we have to determine the total tablet thickness, we have to use the vernier calipers. This is the vernier caliper that is also being used in physics in order to measure the thickness of different kind of metallic sheets. So in case of, if we want to determine the total thickness or the total thickness of the tablet, we have to use the vernier calipers, and if we want to determine only the crown thickness, we have to use the micrometer. Okay, and the total variation in the tablet thickness should not be lies beyond the value of 5 plus minus 5% variation of the standard value. Okay, so if the thickness of a given tablet is 3 mm, okay, yes, so all the tablets should lie in between either plus 5%, their size or their shape can be, or either minus percent, they can vary. Otherwise the given batch is not accepted. Okay, then we comes to the organoleptic property. So this is all about the shape and size. That is going to be very easy. If we want to determine the crown thickness, then it is determined by the micrometer, and if we want to determine all or whole the thickness of the tablet, we have to use the vernier caliper as shown in the figure. And the total thickness value variation is allowed in a range of plus minus 5. Either it can be plus 5% or either it can be the minus 5%. Okay, yes. Then we comes to the organoleptic properties. The organoleptic properties is mainly the property that is being seen by our organ, by our sense organs. Okay, yes. The non-uniform color distribution, that is also known as what? That is also known as mottling. Okay, mottling. And yes, we have to discuss one more thing. The separation of a tablet into its body and crown is known as what? You have to study about two kind of defect in tablet. The first is capping, that is mainly separation of the head and the body of the tablet, and the second one is known as lamination, in which the tablet is going to be separated into multiple component. Okay, so if we are discussing about the lamination, we are separating the tablet into various components or into various fragments one by one. But if we are discussing about the capping, there is only two parts of the tablet that are dissociated from each other. One is the head and other is the body. And the non-uniform color distribution, that is known as mottling. Okay, the instrument that is used for the color evaluation, the first one is going to be the reflectance spectrophotometer. Yes, this is going to be very important. Okay, the second one, that is going to be in order to check the non-uniformity of the color if present in a case of color coating that is being performed over the tablet surface, we have to use the tri-stimulus calorimetric measurements and micro-reflectance photometer. Okay, so micro-reflectance photometer is the one instrument, the tri-stimulus calorimetric measurement is the one instrument, and the reflectance spectrophotometer is the another equipment or instrument we are going to use in order to check the organoleptic properties. Okay, yes. Then we comes to the another property that is going to be the hardness. Okay, yes. So how we can decide a given component is hard or a soft? We can say a bubble, a soap bubble is a hard or soft. We can say that its crushing strength, if a given rock is hard, like if we are talking about the rocks, okay, we can say that given rock is soft or hard on the basis of the strength that is being required in order to crush that particular rock. Yes, so the hardness is also known to be as the crushing strength. Okay, how much energy that will be required in order to crush that particular component. Yes, there is a Haeckel plot. There is a Haeckel plot that is mainly related, the crushing strength of the tablet is mainly correlated with that of Ky value. Okay, the larger the Ky value is mainly an indicator of the harder tablet. So the crushing strength that is also known to be as the hardness is directly correlated or directly proportional to the Ky into the in the Haeckel's plot. Okay, yes. Coming towards our next slide, then we comes to the one of the our official test, the first official test, that is going to be the official test, friability test. Yeah, the equipment that is being used, that is going to be very, very important and asked multiple time in the exam, the Roche fibrillator. This is the kind of device that is known to be as the Roche fibrillator or Roche fibrillator. Okay, so the company that manufactured its first time is a Roche. Okay, so that's why given the name Roche fibrillator. Okay, and they are mainly the friabilities of the tablet is being tested. This given equipment will mainly moves in that way, and the tablet will be present on that part. They will be move upside and then fall from that height from there to here in order to check the friability or the strength of the given tablet. Okay, and the durability of the tablet will be mainly tested by the shock and the abrasion. Yes, the shock is mainly done if the tablet has been dropped from here to there, and the abrasion is mainly done by striking of the tablet with the another tablet and also striking of the tablet with the walls. Okay, so the what phenomena the fibrillator is using, the shock and the abrasive phenomena. Okay, yeah, the friability or and increase into the upper punch pressure, we can mainly relate or solve the friability. If the given tablet is highly friable and is highly susceptible to the shock and the abrasion, then we have to just increases the force of upper punch. Yes, we have to just increase the force of upper punch. Okay, and we have to, the first thing we have to do is the adjustment or increasing the pressure of upper punch. The second thing we have to do addition of more binder to the tablet. Yes, what binder do the tablet? The binder will mainly increase the binding strength of that of the tablet. That's why will not allow the particular tablet to break down into the components due to the shock and the abrasion forces when they are dropping from that Roche fibrillator. Okay, and we can also say that we can also increase the moisture content of the tablet in order to reduce the friability, because the moisture directly or indirectly will also related to increase the cohesion force in between the granules and overall increasing the strength of the particular tablet. Yes, the friability of the given tablet is being calculated by a formula that is mainly indicated by the initial weight of the tablet, that can be denoted by W1 minus the final weight of the tablet and divided by the initial weight of the tablet. Yes, so they are mainly saying or calculating the loss in the mass of a tablet when it is mainly subjected to the Roche fibrillator is mainly an indicative of its percentage friability. If the percentage friability is more, then we can say the difference in between W1 and W2 is going to be high. Yes, W1, if the W1 is very less than as compared to W2, then we can say what? The percentage friability is very high. The percentage friability is very high. Okay, so we can also say like this formula can also be written as that F is equals to 1 minus W naught is the initial weight and W is the final weight. Okay, yes. So there are different kind of condition or different set of condition or the time to which we have to expose the given tablet to that particular shock or aberration condition or to the particular Roche fibrillator. Yes, we have to use the tablet will be fall from, yes, if the tablets are falling from that distance is of 6 inch. The speed of this rotator is of how much? It is RPM, 25 RPM. It is mainly rotating 25 times per minute. Okay, the time for which the tablet are being subjected to that particular fibrillator is going to be 4 minutes. The question is being asked multiple times, then how much RPM a tablet will revolve in a particular set of friability testing. The given tablets will revolve around 100 rounds. Okay, the total resolution, yes, here written 100 rounds. We have to subjecting for a time of 4 minutes. The percentage acceptance criteria for the friability, like for the as per of NIP, Indian Pharmacopoeia, it is not more than 1% friability will be allowed. But as per of USP, the 0.5 to 1% can be the range. Okay. So if the friability is found beyond that particular 1%, okay, so we have to reject that particular tablet batch. So yes, for IP, yes, for IP, it is 1% acceptability, and for USP, it can be lies in between 0.5 to 1%. Not more than even not 2% is, even 2% is not allowed. Okay, there is a strict rule that is being related to the official test that are mentioned into the pharmacopoeias as that of the friability is. So yes, for IP it is 1% and for USP it is can be in between 0.5 to 1%. Okay, so it can also be variable as per of the drug mass. As the drug mass is going to be increases, yes, we are mainly using 85 mg here, 85 to 250 mg tablets, or the tablet having their tablet mass greater than 250. So as the tablet mass is going to be increased, as we are going downward, the tablet mass is going to be increased, then the percentage variation in the friability that are allowed is going to be decreased. Okay, tablet mass is going to be increased. Yes, mass is increasing if we are increasing, if we are using, if we are moving here to there, so then the percentage allowed friability will going to be decrease. As that of the IP, they are mainly saying that 10% plus minus 10% of friability is allowed for less than 85 mg of tablet, plus minus 7.5% of friability is allowed for a tablet having its mass in between 8.85 to 250 mg. But for a tablet that having their mass very larger, that is 250 mg, only plus minus 5%, plus minus 5% of the weight variation or the friability is being allowed. Okay, as per of IP. Yes, but as per of USP, they are taking the lowest weight of a tablet 130 mg, but for the IP, we are taking the lowest weight of the tablet 85 mg. So they are mainly allowing plus minus 10% variation of friability for a tablet that is of 130 mg. For 130 to 324 mg tablet, they are mainly allowing plus minus 7.5% of friability, or for a tablet that having its mass greater than 325 mg, they are allowing a plus minus 5% loss or fibrillation. Okay, so as the mass of a given tablet is going to be increased, so the percentage variation that is being allowed for that particular tablet is going to be decreased, because we know that 10% of 85 mg is going to be very less as compared to 5% of 250 mg. Okay, so we have to normalize these values. That's why we have to take different or have to allow different percentage of friability range. Yes, then we comes to the weight variation test. The weight variation test, that is going to be another kind of test. The weight variation test, the procedure of a weight variation test, randomly we have to select from a batch of a drug that will contain thousands of drug. We have to just select 20 tablets. Okay, then we have to weight each of these tablet individually. After weighting each of these tablet, we have to take the average of all these weight. Okay, so we have to take the average of all these 20 tablets. Okay, then after taking the average, they are mainly saying that not more than 2 of the individual weight deviated from the average weight by more than the percentages that are being given into the next table. Okay, so they are mainly allowing only 2 tablets out of 20 tablets that can only be lies their weight variation beyond a particular acceptable range. If it is going to be 3 tablets having their weight variation ranges beyond as mentioned in the table, then the batch is rejected. The batch is only expected or accepted in the case when we are taking 20 tablets and only 2 tablets are showing their weight variation beyond the particular allowable range. The allowable range. Okay, yeah. So they are only allowing 2 tablets to vary their content. Okay, then we comes to the content uniformity test. In the content uniformity test, we have to emphasize here we are taking 30 tablets and at least 10 by the analytical techniques we have to assay, or the assay is mainly used to done in order to check the content of given active pharmaceutical ingredient that is present in a given formulation. We can also use UV spectroscopy for that purpose in order to check the quantity of a given component, or in order to confirm the given component that is present in a formulation. We have to use the UV spectroscopy. Okay, the content uniformity test is passed only if we are taking the 9 medications. If we are out of 30, they are mainly saying out of 30 medication, if 9 tablets out of 30 tablets, if 9 tablets contains 85 to 115% of the content, yes, so it is mainly showing what, plus minus 15% of variation is allowable for 9 tablets, and 10 tablets are allowed to have their variation of plus minus 25%. Okay, if the above condition is not satisfied, then we have to take 20 more tablets, 30 plus 20 more tablets. So in total 50 tablets we are taking. If the given above condition of 9 and 10 tablets is not satisfied, we have to take again the 20 tablets, and all the 20 tablets having their weight variation in a range of 15%. Yes. Okay, so this is as simple as that. Okay, let's discuss it here. First we have to take 30 tablets. Okay, out of these 30 tablets we have to take 9 tablet. Okay, first we are discussing about in what condition the test is being passed. Okay, so first we have to take the 30 tablet. Out of these 30 tablet, 9 tablet are allowed to having the content variation in between 50%, 15%, and the 10 tablets are allowed to having their content variation in between plus minus 25%. Okay, so if this condition is followed, then the test is passed. So there is another condition that can arise. The test is failed. So if the test is failed, then we have to take 20 more tablets. And that time we have to ensure that all the 20 tablets should have their content variation in between plus minus 15%. Yes. Okay, so this is the content uniformity test, is a kind of official test. Okay, then we comes to the disintegration test. Yeah. So disintegration test, there are different kind of condition or disintegration equipment. Yes, we are mainly showing in that. So this is mainly the disintegration equipment or instrument that will mainly contain the 2 beakers. Each beaker is of 900 ml volume. Okay, yeah. So this is mainly the basket of this DT that will move in a direction of forward and backward direction. Okay, so we have to set the RPM in which it will be moved forward and the backward direction, and we have to place the tablet through here to here. So there are how many baskets are there? 1 2 3 4 6. So there are 6 baskets here, and there is a small mess are present at the end of each basket having a particular mass size. Okay, so this is mainly the basket rack assembly or the different part of that particular disintegration apparatus. Okay, so they are mainly showing the configuration of that particular disintegration apparatus. So how many glass tubes are there? There are 6 glass tubes, and each glass tube is of how much width? It is of 3 inch in width. Okay, yeah. Then we comes to the, as per of USP, as we discussed, there is a mesh that is present at the end of each basket. We have discussed that as in the USP apparatus, it is of 10 mesh size, but for the IP, it is of 8 mesh size. What is the diameter of 8 mesh size? That is 2 mm. And what is the diameter for the USP? That is 10 mesh size, that is 1.7 mm. Okay, so what solution we have to take into the beaker in order to simulate the gastric fluid? Yes, we are mainly taking the consideration of simulating the condition or mimicking the condition. We can also say simulating or mimicking the condition of intestinal fluid. So we have to mainly take 1 liter of a beaker that will mainly contain 0.1 normal of HCl in it. So we are also have to provide the temperature that is not shown here, but there are some heating coil that is located inside below these two beakers that will heaten up all the solution of this beaker. Okay, so the temperature of that solution should be in between 37 plus minus 2 degrees Celsius is allowed. Okay, and the distance, as we discussed earlier, that the given basket will be moved in a forward to the backward direction. So for how much distance we have to move that particular basket, the basket have to be moved a distance of 5 to 6 inches. Okay, and how much frequency or how much cycles it will be repeating in 1 minute? Yes, it is mainly repeating 28 to 32 cycle, dip cycle, up cycle, dip cycle, up cycle. They are mainly utilizing 28 to 30 cycles per minute. They are mainly repeating. Okay, so this is all about the configuration of that particular disintegration apparatus. Okay, that is going to be asked in different DI exam multiple times. Okay, as it is a kind of official test as mentioned in the pharmacopoeia, so that is going to be very, very important from your exam point of view. Okay, yes, and they are also asking the in first question in this point, they are mainly giving that the given basket will be moved at a distance of 5 to 6 inches up and down. So they are mainly asked that how much distance that the tablet has to be traveled then if the basket is going down and up. Okay, so yes, so if this basket is going down, if this basket is mainly going down and up, then the tablet if located here, it will also move some distance in upward and the downward direction. Okay, so if the given tablet is mainly moving in a downward direction, it can be due to its gravitational force. But if it is moving in an upward direction, it is due to the buoyancy of water, buoyancy of solution. Okay, so there are two forces that are also acting. So the tablet will always remains 2.5 centimeter below the surface of liquid. So if this is the surface of the liquid, the tablet has to be removed at least, has to be remain at least 2.5 centimeter below to that of the surface in the upward movement. When the basket are moving upward, the tablet should present at least at a distance of 2.5 centimeter below that of the liquid. And at the time of descent or going down, that they will not go closer than that of 2.5 centimeter to the bottom of the beaker. Okay, so there is a condition of 2.5 centimeter. Either the given tablet is going, either the given basket is going upward or downward. Okay, there is a condition of 2.5 centimeter rule. You have to just remember. Okay, yes. So coming towards our next table, that is going to be the limit of disintegration test as per of IP, Indian Pharmacopoeia and United States Pharmacopoeia. Yeah. For the dispersible tablet, we are mainly taking the media into a disintegration apparatus. The media is going to be the water at a temperature of 24 to 26 degrees Celsius. Okay, the disintegration time for the dispersible type of tablet as per of IP, it is 3, it is in minutes. Okay, and for USP, it is also going to be 3 minutes. Yeah. Then comes to the effervescent tablet. Effervescent tablet, as it indicates having 2 F's. So we can say F stands for 5. So the dissolution media for a effervescent tablet, and whenever anyone taking 250 ml of the dissolution media, so they are mainly indicating a higher dissoluting tablet. It is mainly done for a tablet that will release that content very rapidly. That's why we are taking that lesser amount of solution in which we are mainly testing the disintegration. Okay, so it is going to be 5 minutes for both USP as well as IP. Then comes to the uncoated tablet. The only water is taken as a media, disintegration media, and the time should be, yes, you have to remember, for the uncoated tablet, it is going to be 15 minutes, 15 minutes, 15 minutes for the IP and 30 minutes for the USP. For the film coated tablet, we can either use water or can use 0.1% or 0.1 normal HCl. And yes, the 30 minutes is going to be the time for the disintegration of that particular film coated tablet. Okay. For the vaginal tablet, as that of the film coated tablet, we can use water for it, and the disintegration time will be going to be 30 minutes for both IP as well as USP. This is also going to be very important for the sugar coated tablet. The water is acting as a disintegration media, and the disintegration time is 60 minutes for both USP and IP. For the enteric coated tablet, if we are using 0.1 normal HCl, then the time for IP is going to be 120 minutes, and for USP it is going to be 60 minutes. But if we are using the phosphate buffer, then it will going to be reversed. Okay, yeah. So we have to just remember, if it is 0.1 HCl, if we write IP and USP here, for an enteric coated tablet it is going to be 120 and 60, and for the phosphate buffer the trend will be reverse. So these are the different disintegration time as per of IP and USP that is being decided for the different kind of tablets. Yes. Then we are going towards the different another test, that is going to be a dissolution test. Dissolution is what? Dissolution and solubility. What is the difference in between the dissolution and solubility? Okay. Yes, you have to tell that. What is the difference in between the dissolution and that of the solubility? Yeah. The dissolution is a process and solubility is a kind of state. Okay. The process by which the solid solute will then enter into that of the solution. Yes, dissolution is a process by which the given solid solute or the content from that given solid formulation will slowly leaches or reaches to that of the bulk of the solution, is known as dissolution. In the pharmaceutical industry, it is defined as the amount of drug that will goes into the solvent per unit time. Or we can also say, then in the pharmaceutical industry, the dissolution is mainly related to the rate of release of drug. Rate of release of drug into solution. Okay, and the standardized condition is like, it is like, if it is a solvent, then it is a solid, or then it is a liquid. So the condition is a solid liquid interface. Okay, temperature and the solvent composition. Okay, so dissolution media, what is the volume of the dissolution media? Yes, it is fixed. It is of 900 ml. Number of tablet we have to take 6 tablets. The time we have to take a specific time, 1 hour of time for the conventional tablet or the normal tablets, and for a sustainable release tablet or the long acting tablets, we are mainly use a time interval for the checking of samples is taken 8 hours. Okay, the minimum time for the sustainable release tablet. The sampling interval can be for a sustainable release tablet, as the name indicated, it will mainly releases, it contains sustainably or after a very long interval of time. Yes, for the sampling interval, yes, we have to take the first sample. If we have to take the first sample in case of conventional dosage form, if we are taking the first sample at 5 minutes, then at least we have to take the second sample in the conventional release dosage form after 10 minutes of it. Like, if we are taking the first sample at 5 minutes, we have to take the second sample at 15 minutes at least. And if we have to take the first sample at 15 minutes, then we have to take the another sample at 30 minutes. Okay. So yes, 5 minutes, 15 minutes, 30 minutes. But 1 hour gap is being needed. Like, if we are taking 30 minute sample, first sample at 30 minutes, then we have to take another sample at 1.1 hour 30 minutes. Okay, yeah. So these are the sampling intervals. And the temperature of the media in the dissolution condition, it is going to be 36.5 to 37.5 degrees Celsius is going to be temperature. So these are the mainly conditions. The dissolution media that is of 900 ml. The vessel capacity is of 1000, but we have to fill the dissolution media up to 900 volume of its capacity. Not we have to fill. Okay, we are not filling the full content out of it. If its capacity is 1000, we have to just fill it to the 900. The temperature that has to be kept in the dissolution media 37 plus minus 0.5 degrees Celsius. The RPM at which the paddles are going to be rotated, says these are the different kind of paddles that are present in each basket. So these paddle has to be rotated at a rotation of 25 to 150 RPM or rate per minute or round per minute. Okay, the shaft position. So these are the shaft that is being mainly rotating that particular paddle. The axis within the 2 mm of the axis of the vessel. So the shaft has to be rotated in the 2 mm of axis of the vessel. So this is the vessel, and the shaft have to be rotated in the 2 mm of its axis. Okay, and the longer edge of the blade. So this is going to be the longer edge of the blade, and this is going to be the shorter edge of the blade. So the longer edge of the blade is 23 to 27 mm from inside of the bottom of that of the vessel. Okay, so this is the inside of the bottom of that of the vessel. It having a distance of around what, 27 to 23 mm. So all these things are taken constant here because they can alter or change the dissolution. If that particular distance in between the paddle and the media is very less, then it is going to affect the dissolution of the drug, or the paddle may, if the tablet is mainly present here, if the paddle is mainly present at a very down position, then it may also stuck with that of the tablet and will mainly sometime increase the dissolution of that particular tablet. That's why we have to even put these shaft mobility as well as the blade position constant for the dissolution apparatus. Okay, yes, the shaft rotation speed, that is 25 to 150 RPM, can only vary 4% plus minus. Either it can be plus 4% or either it can be minus 4%. Yes, so we can say like, what is 4% of 25 RPM, or what is 4% of that 150 RPM. So very less error is being allowed in it. Okay, and the sugar coated and the gold coating, not the sugar coating, the gold coating thickness that is present in each of that paddle is going to be very, very, very thin. That is going to be multiple times is being asked in exam, either by a value of 2.5 micrometer, or we can say gold is very expensive, so very, very less amount of gold is being used, 0.0001 inch, because inch is going to be very, very larger unit as per of gold coating. Okay, so these are the different criterias. Yes, so there are different kind of dissolution apparatus as per of IEP and USPs. So as per of USP, we are discussing the first one is a basket type of apparatus. Okay, what is in basket type of apparatus? The dissolution media is going to be same, 900 ml. The capacity is 1000 ml. The temperature is going to be 37 plus minus 0.5 is allowed. Yes, the speed is also going to be that we have already studied, 25 to 150 RPM. The shaft rotation, the shaft has to be rotated at its axis, that is only allowed to 2 mm from the axis of that of the vessel, within the axis, within the 2 mm from the axis of the vessel. We have already discussed the lower edge of the blade. The lower edge of the blade should be 23 to 27 mm away from that of the bottom of the vessel. Yes, we have already discussed why the given smaller things are even keep constant, because they can even alter the rate of dissolution. And the fifth one, the shaft rotation speed can be only allowable ranges plus minus 4%. Okay, not more than that of the 4%. If the shaft speed is going to be increased up to a higher content, then it may also alter the dissolution that we are not going to bear, and will give the fake results, or the result that we don't want. The gold coating is of 0.0001. The second comes to be the paddle, or the type 2 USP apparatus is going to be the paddle apparatus. The dissolution media is same, 900 ml we are taking. The vessel capacity as such 1000 ml. The temperature of the vessel, yes, 37 plus minus 0.5 degrees Celsius is being allowed. The speed of the shaft we are mainly using the same, that is 25 to 150 RPM, and the shaft position is also going to be same, not more than 2 mm from that of the particular axis of rotation of that shaft. Okay, yes, the one thing we have to remember or is slightly difference, or but we can say like it is also lying in a range of 23 to 27 mm. No? So it is mainly the 25 mm is mainly the distance in between the lower edge of that of the blade to that of the bottom of the vessel of dissolution. So this is about paddle and the basket type of apparatus. Then we are discussing, as we are discussing about the dissolution, we have to discuss about the 𝑘𝙀𝑉𝑖𝑡𝑛 equation. Yeah, they are mainly, the 𝑘𝙀𝑉𝑖𝑡𝑛 equation is mainly given in order to determine the rate of dissolution or the factors that are going to affect the dissolution. Okay, and we are mainly seeing an increase in the dissolution rate will be observed whenever there is a particle size reduction or micronization will be there. Okay, so there are two processes, either they can be the nanonization or can be the micronization. Okay, yeah. So they are mainly asking about the micronization. So whenever we are doing the micronization, it will going to increase the dissolution of the tablet. Yeah. But if we are using or making the particle size reduction by using the nanonization, it will mainly increase the solubility. Okay, so this is also going to be the important point. So what is the Noise-Whitney equation? This is the Noise-Whitney equation, that is dc by dt is equals to dA by hv. That is mainly, D is mainly an indicative of diffusion coefficient. So if this is a tablet, so there is a mainly transfer of the drug from that of the core or the surface of the tablet to that of the bulk of the solution is mainly done or determined by the diffusion. H is mainly going to the thickness of that particular diffusion layer. A is the surface area of drug that is being exposed to the, so that is going to be the surface area that is being exposed to the total dissolution media. And V is going to be what? The volume of dissolution media. The volume of dissolution media. C is mainly the concentration of, we have to remove it from here. So C is going to be the concentration of the saturated solution that is formed just at a slightly distance or a very close, just in a very close proximity to that of the surface, is the formation of a saturated solution, or high, or we can also say a high drug concentration solution. So this is the tablet surface. So here is a region that is located in the proximity to the drug surface is known as a saturated solution region. Then comes to the concentration of drug in the solution. So the point that is mainly far away from that of the drug is known as the bulk concentration, that is denoted by the C, and dc by dt is mainly the dissolution rate. So they are mainly talking about the different factor that can affect the rate of dissolution. That can be the diffusion coefficient, that is denoted by D. That can be the thickness of the diffusion layer. That can be the volume of the media we are using. That can also be the surface of drug that is exposed or in contact with that of the dissolution media. That can also be depend upon the concentration of saturated solution, how much concentration of that given drug is present in the saturation condition, and that will also depend upon the concentration of the drug in the solution at a particular time t. That can be the smaller time, that can be the higher time. If the particular concentration is going to be high, then the rate of dissolution will also going to be high. So this is the Noise-Whitney equation. Yes, so this is going to be very, very important. Moving towards our next, there are different kind of USP dissolution apparatus and their applications. The first one we have to remember with the trick. This is the kind of USP apparatus. Okay, yeah. So there is a cycle. The first apparatus is mainly going to be the basket. Okay, the second apparatus is mainly going to be the paddle. So this is mainly reverse in the case of IP. Okay, for the IP, and first one is mainly the paddle, and the second one is mainly going to be the basket. Okay, yeah, but we are discussing about the USP, United States Pharmacopoeia. The third one is mainly going to be the reciprocating cylinder. There is a cylinder that is present tilted here, that can be known as the reciprocating cylinder. Yeah. Okay, then comes to the fourth, that can be written as flow through the cell. There is a flow in the chain, that can also can be written as flow through cell. And the fifth one is mainly the paddle over disc. We can also remember it with 5 can also be called as 𝘂 in Hindi. So P is mainly stand for 𝘂. So paddle over disc is mainly the fifth equipment. Then we going towards the sixth, that is going to be the cylinder itself again, and the seventh is the reciprocating holder. Okay, yeah. So the reciprocating cylinder is the third one, and the reciprocating holder is the seventh one. Both are odd. Okay, so yes, as per of USP, the first one is the basket, that is mainly allow 50 to 120 RPM we have to rotate, and we are mainly testing that conventional tablet, chewable tablet and controlled release tablet in it. Second is going to be the paddle, that will mainly allow RPM of 25 to 50 RPM. That is mainly being used for a highly disintegrating type of tablet. That can be a question for the orally disintegration tablet, the chewable tablet, or for a long acting or a slowly releasing tablet, that can be the controlled release tablet, or for the suspensions as well. Then comes to the type 3, that is the reciprocating cylinder. We are mainly using 6 to 35 RPM. That will mainly use, as we are using the very less RPM, so it is being used for the controlled release or the chewable tablets. Type 4 is going to the flow through the cell. That is mainly used for the poorly soluble APIs. Type 5th is the pedal over disc, that will mainly allows 25 to 50 RPMs for the transdermal tablets, and will mainly use for the transdermal tablet. 5th and 6th is mainly for the TD tablets, transdermal tablets. This can be the question. This is the important question. Okay, and type 7, that is a reciprocating holder, will mainly utilize 30 RPM, is mainly done for the CDDS. Yes, as the CDDS releases its contents at last or at the slowest speed, so at the bottom or the US or the disintegrating equipment, dissolution equipment that comes to the last, will mainly test the release in of CDDS, controlled release dosage form. We can also remember by that trick. Okay, yeah. So as per of USP we have already discussed. As per of USP there are 7 dissolution apparatus. As per of IP there are only 4, and as per of BP there are only 4. Okay, yeah. So all the 4 can be taken as such for BP, but the only reverse trend that the IP has to be followed from that of the USP is the first equipment, the first dissolution apparatus for IP is going to be pedal, and the second one is basket for the IP. But as per of USP, the first one is basket and second one is going to be the pedal. Yes, this is the only difference. Okay, so the IP limit, as per of IP, what is the dissolution limit or the acceptance criteria for a particular batch? So if we have to take the level of sampling, we have to take 3 samples, S1, S2 and S3. In first sample we have to take 6 tablets, in second sample we have to take 6 tablets, but in third we have to take 12 tablets. Acceptance criteria for the sample 1, where we are taking the 6 tablets. So the no unit dosage form should releases its content greater than 5%. Okay, for the S2 sample, if we are taking also 6 number of tablets, so they are mainly saying the acceptance criteria is the average of 12 dosage unit is equal to or not more than the Q, that is going to be the release pattern itself, and no unit less than. So it is not going to be not more than Q%, the release should be, and not less than Q minus 15%. Okay, yeah, for 12 unit doses form. Then we are mainly taking the 12 tablet in S3. They are mainly saying the average of 25 unit doses form is equals to or greater than Q, but not more than 2 dosage unit form should be less than Q minus 15, or no unit dosage form will be allowed to have. So they are mainly specifying a condition. So it can be Q%, that is normal, but if in case the release pattern not follow for 12 tablets, so they are mainly allowing only 2 tablets that can have their content variation in between Q minus 15%, and no tablet will be allowed to have its release content of, we have to write here, release content of Q minus 25. Okay, so this is the condition for dissolution apparatus. Okay, so what is the difference in between the dissolution and the disintegration? Okay, yeah, the mesh size in disintegration is mainly going to be 10, but for the dissolution the mesh size is going to be what, 40. Okay, so the mesh is mainly present in the kind of basket type of dissolution, apparatus. So mesh size is going to be 40 for it. The temperature, this is going to be very, very important. So the allowable range for the disintegration is 37 plus minus 2 degrees Celsius, but for the dissolution, it is allow only 0.5 degrees Celsius, 37 plus minus 0.5 degrees Celsius. Okay. The RPM at which the rotation is being done. For the disintegration, we are mainly utilizing 28 to 32 cycles per second, and for that of the dissolution, we are mainly utilizing the 50 to 100 RPMs. The tablet remain below the surface, okay, of the liquid, descend not closer to. So yes, we are mainly saying 2.5 centimeter per rule. That is mainly saying that if the basket is moving upward or either downward, the tablet should remain not closer to the surface, should remain at a distance of at least 2.5 centimeter from the surface if the given basket is moving upward. But if the given baskets are moving downward, it should also remain at a distance of 2.5 centimeters from that of the bottom. Okay. And the same distance, that is going to be 2.3 to 2.7 centimeters from the upward and the bottom. The media that has been taken here, yeah, both are mainly taking 900 ml of the media. Okay. Yeah. So yes, this is related to mainly what? This is mainly related to your tablet or oral solid dosage form. Okay. Oral solid dosage form. Yes. So we have to check to the go to another solid dosage form. That can be the capsule. Capsule is also a kind of solid dosage form that will mainly encloses a given compound into it. They can be the hard gelatin or the soft gelatin capsule. They will mainly, the content is mainly being packed into the shell. This is the capsular shell that will mainly mask the taste as well as the odor. And we can't be used the extremely soluble material into that of the capsule shell, like KCl, ammonium chloride and iodine cannot be used into the or can be filled into the capsular shell, because they will mainly cause a sudden release of the material into that of the stomach when ingested. That's why, or can also cause the irritation. This sudden release of all the APIs into the stomach can release or cause the irritation. Okay. Yeah. So there are two conditions. If we are mainly using highly effervescent material, the capsular shell will mainly become soft. But if we are using a deliquescent material, deliquescent is the kind of material that will mainly must absorb the moisture, absorb a higher amount of moisture into it till it liquefies. So if the given material that is present inside the capsule is absorbing a higher amount of moisture in them, then it will soak out all the moistures from the capsular cell and will make the capsular cell brittle. Yes. Okay. So effervescent will mainly make the capsule shell soft, and deliquescent will mainly make the capsular shell what? Brittle. So there are two kind of capsule, the hard gelatin capsule or soft gelatin capsules. So this is mainly the cap, and this is going to be the body of that of the capsule. Yeah. Okay. So like we can say the moisture content in the hard gelatin capsule should be lies in between the range of 12% to 15%. If the content is below 10%, then the capsular shell will become brittle. If it is above 16%, then it will mainly lose the mechanical strength or will mainly softens. Okay, and a higher level, it will absorb the moisture and will mainly become tacky and very tacky and sticky. Okay, so we are mainly using different kind of things like plasticizers or gelatin into the capsules. Okay, so there are different kind of gelatins, either type A that is being isolated from the pork skin, and can be the type B that is isolated from the bones having their pH. The pork skin is the acid titrate precursor having its pH 9, and type B having its pH 4.7. Yeah. Okay, so there are different techniques or the sources from where the gelatin can be isolated. It can be the pork skin, it can be from the calf skin, or it can be from the dry bone through the various processes. Yes, let's come to the and the basis of the concentration of plasticizers that will mainly cause the softness. There are different kind of capsules, like if contain glycerin, that is a plasticizer, in a concentration of 0.4:1 ratio, they mainly form the hard gelatin capsule. If they are mainly utilizing 0.6:1, it is mainly forming the soft medium gelatin capsule. But if they are mainly utilizing a concentration of a plasticizer that is 0.8:1, that is mainly forming a soft gelatin capsule. We can say as the concentration of that plasticizer is going to be increased, the softness of the capsule is also going to be increased. Okay, yeah. Okay, so yes, there are different kind of physiological properties of gelatin that is being checked with the help of bloom strength or gel strength, we can say. We are mainly using that equipment. We have to hang the weight here, and the plunger is being used in a gelatin. We have to mainly check the thicker the gelatin is, more the price of the given gelatin is. Okay, yeah. So we have to mainly ensure that the viscosity of the gelatin, okay, 6% of gelatin in water at 60 degrees Celsius to measure the molecular chain length. More the molecular chain length, more the viscosity of the gelatin. Okay, so viscosity of the gelatin should be lies in between 25 to 45 millipoise, and iron content of the gelatin should not be more than 15 ppm. Okay, yeah. Then comes to the evaluation of capsule appearance. The capsule produced on a small or on larger scale should be of uniform in appearance. Visually as well as electronic inspection should be undertaken in order to detect any kind of defects. Flaws can also be say the defect in the integrity as well as in the appearance. Yes, so we have to just check the appearance, like the appearance is uniform with there is no flow into the integrity. So first we have to do the same test that we are performing for a tablet. We have to take the 20 capsules, then average their weight. Each capsule weight should be determined individually. Then we have to take the average of it, and the individual weight of the capsule should not be less than 90% and should not be more than 110%. So plus minus 10% variation is allowed. Okay, and original 20 capsule do not, if these 20 capsule will not satisfy or meet the criteria, then we have to take more capsules again. Okay, in order to determine the content uniformity. Okay, yeah. So the percentage deviation that is being allowed here, for less than 300 mg of capsule size, there is plus minus 10% variation is allowed. For a capsule that having its size more than 300 mg, plus minus 7.5% weight variation is being allowed. Content uniformity, yes, in the same way we have to take the 30 capsules. 10 are mainly analyzed, not more than 1, but less than 3, like 1 to 3 capsule. From the first 10 capsule should not have, so they are mainly allowed, the 3 capsule is being allowed to have their percentage variation plus minus 15%, and remaining 20 is being assayed. Okay, yeah. The requirement is meet if the 30 capsule are within the, so all the 30 capsule if are present in the range of plus minus 25%, then the required condition is being matched. Okay, so for the disintegration we are using capsule, so mainly the soft gelatin capsule having a disintegration time of 60 minutes. Okay, and for the hard gelatin capsule the disintegration time of 30 minutes. The enteric capsule that is being used a media of 0.2 molar HCl should not disintegrate within 120 minutes, or enteric capsule in phosphate buffer that having its pH 6.8 having its disintegration time of 60 minutes. You have to remember all these points. Okay, so the dissolution test, we have to take 1000 ml of water, then we have to dissolve free from that of the dissolver at a temperature of 65 to 37 degrees Celsius. Yes, we are mainly taking. Then specific number of capsule we have to place in it, and will rotate the motor at 100 rpm of speed, and then we have to withdraw the sample of solution after 45 minutes and filter the weight, and we have to amount the active ingredient. We can also check with the help of HPLC, high performance liquid chromatography. If the amount of ingredient in the solution is not less than 70% of the start amount, then the test is passed. Yes, if we are taking the first sample after 45 minutes, the content that is being released into the solution should not be less than 70%. If it is not less than 70%, yes, the test is being passed. Okay, so there are different kind of terminology that can be used. Soft spots is nothing. If the capsule is lying next to the another capsule or next to the tray, is known as soft spot. Okay, so if you eat much higher amount sometimes in party, then we can say like some bloating is occurring in my stomach. So in the same way, if the given capsular cell absorb a higher amount of moisture in it, it will mainly cause bloating in the capsular cell. That is about 60% of the capsular size will be enlarged as your stomach enlarged due to higher eating habits. Okay, the foreign capsule is being procured from a foreign company. We can say the unfilled capsule is being procured from a foreign company. So we can say the empty The empty capsule cell is also known as foreign capsule. Okay, so I hope you guys enjoyed that particular session that is related to your Tamil Nadu DI exam and is related to all the quality control tests, some of the basic information we have discussed about the tablet, the capsule, and also the different kind of official and non-official tests that are being related to your solid dosage form for the tablets, for the capsules, and the different conditions and the different limits in which the given acceptance is being allowed for these solid dosage form. I hope you guys enjoyed that particular section. Thank you for giving your precious time. All these things are going to be very, very important for your coming examination. Thank you for giving your time. Thank you all.